My class has an assignment question on writing a program solving the ideal gas law. So I'm going to show them how to do it and share it with you by teaching you how to work with kinetic energy. So we're going to write a program that will solve the kinetic energy equation for either mass, velocity, or energy by using Python. So kinetic energy from physics is 1/2 mass times the square of your velocity. So this relates how much energy a moving mass has based on how massive it is and how fast it's going. So let's say I was working with this equation and I wanted to write a program to help find mass, velocity, or energy. Obviously, you would need to know the other two variables. So the first thing our program is going to have to do is ask, what are you looking for? Are you looking for mass, velocity, or energy? So number one, program is to ask, what are you looking for? So I'm going to say variable equals input. What are you looking for? Mass, velocity, or energy. Okay, now if they're looking for energy, that's going to be the easiest one. So I'll start there. If variable is equal to energy, let me make that lowercase just so things line up. If they're looking for energy, what do I need to do? Well, if I'm looking for energy, I need to know mass and velocity. So we're going to have to ask them. Ask what you're looking for, and then two, ask for the other variables. So if the variable you're looking for is energy, then we need to know mass. So M equals input is the mass. And V equals input. What is the velocity? Now they're going to come in as strings. We got to convert them so we can do some math to them. If you knew they were never going to use decimals, you could use int, but because they might use decimals, we use float. So M equals float M. So we're going to convert these. V equals float V. And yeah, you could do that all in one line, but I want this to be clear to whoever's watching this for the first time. So if the variable is energy, we ask the user for the mass, we ask the user for the velocity, we convert them so we can do math to them, and then energy is going to be equal to, and here's our equation that governs it, energy is half mass times the square of velocity. So energy is 1/2, which is 0.5, times the mass, times the velocity squared, so times v, and remember we use 2 stars for squared. And then we can print the kinetic energy is, and we'll round it. Let's round our energy to 2 decimal places. Okay, so let's just test this before we go any farther. So I'm going to run that. And And it looks like I forgot a round bracket here. There we go. What are you looking for? Well, this only knows how to deal with looking for energy, so I'm going to say energy. The mass is 3, and the velocity is 2. And it's telling me the energy is 6. Now let's just check to see if that's right. 3 times 2 squared is 12, divided by 2 is 6. So yeah, this is working. Okay. Now, what if they're not looking for energy? What if they're looking for mass? So remember here, we've asked them, what are you looking for? If they're looking for energy, we did this. Now, if they're looking for mass, so if the variable they're looking for, if the variable is equal to mass, then it's pretty similar to this, except, so I'm just going to copy it and make changes to it. If I'm looking for mass, I can't ask the user the mass. I'm going to ask the user the energy. E is equal to input. What is the kinetic energy? So I'm then going to convert my energy into a float. V, what is velocity? Yes. Now I've got to change this equation here. Because remember, it's m that we're calculating. So instead of the kinetic energy, I'm going to say the mass is, and it's m. So now I just have to figure out what is the mass. Okay, if energy is half mv squared, energy is 1/2 of mv squared. And we're looking for the mass. We've got to do a little bit of math here. The opposite of multiplying by a half is multiplying by 2, because multiplying a half is dividing by 2. So I'm going to multiply both sides by 2, so I have 2 energy is equal to mv squared. Now mass is being multiplied by v squared. The opposite of that is dividing by v squared. So m is 2e over v squared. So now I'm going to enter that here. M is equal to 2 times e divided by v squared. I'm going to use brackets so that it squares v before dividing that quantity from 2e. Let's give this a try. So now it should know how to deal with looking for mass. So what are you looking for? I'm looking for mass. What is the kinetic energy? So let's say my kinetic energy is 12 and my velocity is 4. Then my mass must be 1.5, because half of 1.5 times 4 squared is going to give me 12. Okay, finally, and this is going to be the toughest one, what if they're looking for velocity? So if the variable is equal to velocity. Now, the reason why this one's the toughest is velocity is being squared, so mathematically it's the trickiest one to solve. So just like the others, I'll just copy this and then make small changes here. Okay, if I'm looking for velocity, I must know energy, and I also must know mass. So I'm going to get rid of that and steal this one here because I'm looking for mass. So if I'm looking for velocity, I must ask the user what is the kinetic energy, what is the mass, and then I've got to calculate the velocity. And then finally, I will say the velocity and I'll put a v there. Okay, so how do I find the velocity? Let's do a little bit of math to this. So we start out with energy is 1/2 mv squared. I'm going to multiply both sides by 2 to get rid of the half. So 2 times energy is mass times velocity squared. I'm then going to divide both sides by mass. So 2 times energy over mass is equal to the velocity squared. That makes the velocity the square root of 2 times energy over mass. So I want the square root of 2e over m. So I'm going to go here, and the velocity is equal to, now remember, to get the square root, we have to import the math library into Python. So I'm going to go import math. So I want the square root, that is math.sqrt, and I want the square root of 2 times e divided by m. So that's 2 times e, and then I'm going to divide that by m. So then I'm going to round and print it, and let's just check to see if this works. Oh, made an error here. Remember, when you're checking with an if statement to see if something's equal to something else, you need a double equal sign. So what am I looking for? Let's say I'm looking for velocity. So what is the kinetic energy? Let's say the kinetic energy is 25 and the mass is 3. Then my velocity must be 4.08. So the assignment you're given is based on the ideal gas law, not on kinetic energy. And the ideal gas law is pressure times volume is equal to the number of moles times a constant times the temperature. So it relates how much gas there is in a container to the amount of pressure, the volume of the container, and the temperature that it's at. The hotter a compressed gas is, if we raise the temperature, that's going to raise the pressure or the volume. Now, if it's, say, a steel container that will not expand and the volume stays constant, the pressure goes up. That's how like a pressure cooker works. If it's a balloon where it is stretchable, then the volume will increase along with the pressure when you increase the temperature. So this relates the temperature, the volume, and the pressure of a gas to how many molecules are there. Now that's the number of moles, not just the number of molecules, because it's an astounding number of molecules. And then that number R just makes it all work together. So when you solve this problem, you're going to have to look up a value for R, do a little bit of research, and make sure that your value for R is consistent with the units you're using for volume, pressure, and temperature.